All right, so this problem is quite involved, several steps. This would be a good paper 2 question for us. And so we're given this particular triangle here with the various measurements. And notice one thing, we're in radians, so be careful with our calculator. First part is we want to show that this statement is true. Well, if I look at this, I have an angle, I have my 3 sides, and I have a cosine. So I believe the cosine law is going to work. And then I'm going to find P. Once I have P, I then will have these 2 sides, and I can go to the next part. But we don't need this bottom part here, so let's make some space here and just work for this scenario here. And so, using the cosine law, I know that 6 squared is equal to 5p squared plus the 4p squared minus 2 times 5p times 4p, cosine of 0.7. And so if we work through this somewhat, this is going to be 36 is equal to 25p squared plus a 16p squared minus, well, that's 20 times 2 is 40p squared, cosine 0.07. And so now I get this is equal to 25 and 36 minus 40 is going to be 31p squared. Oh, hold on. Hold the horses. I was checking what it was, but I can't actually do this one because there's a cosine there. So let me try that again. So if I say 25 plus 16 is 41p squared minus 40p squared cosine 0.7 is equal to 36. The last thing I do then is I just factor out a p squared. And so I can say that 36 is equal to p squared, 41 minus 40 cosine 0.7. Okay, and so in these IB questions that we're asked to do, show that. You can't skip too many algebra steps. You have to clearly show what it is going to, how you got the steps. Now I want to find P, which should be fairly straightforward. I'm just going to divide by this whole side. And so P squared will be 36 divided by 41 minus 40 cosine 0.7. And then I end up taking the square root of this. And so if I do that, if I go, I'm going to make sure my mode is in, I have to switch it to radians. In trigonometry, you really have to be careful what mode you're in. It is often a common mistake to forget to switch it. Okay, and then I'm going to put it into a fraction. And I have 36 and 41 minus 40, 40 cosine 0.7. Just check I typed it in correctly. And I think I might need that in handy. Let's store that into alpha A just for fun. But I get my p-value. My p-value is going to be 1.86 to 3 significant figures is what p is. All right. And so there is A part done. I have a feeling I'm going to need this p-value for B part when I move on to B part. So I'm going to take that and move it with me. Okay, so taking P with me here, I consider the circle at center B, passes through the point C, and cuts the line CA at D. And this is an obtuse angle. BDA, or ADB, is obtuse, so more than 90. Part of the circle is shown in the following diagram. So here's where the circle is going to be. The circle will be here, scenario. Okay, and there I can see that is, if that's the case, I should be able to recognize that that's a circle. And so I know that BD, this length here, is also going to be 6 because they're both radiuses of that circle. And so BD is equal to 6. The write down command usually means that there's very minimal computations to do. It could be a quick rearranging or just an insight into something. So now I want to find ADB down here. Well, I can see, I know that this length here is 4p, and p is 1.86 with lots more decimal places. And so what I can do is if I have this side and this angle, I could find this angle C up here, which will find me this, which will find me this by using the sine law. And so I can say that the sine, or yeah, I will say the sine of C, the sine of C over 4p over 4 times a 1.86 is equal to the sine of 0.7 over 6. And so now I can find sine C is just going to be 4 times the 1.86 sine of 0.7 radians over 6. And so and then to find C, I can just do the inverse of, I can go inverse of sine, where it's 4. Remember P, I called it A, sine 0.7, close a parenthesis, divided by 6, and I'm going to close it. And so my C value, this is in radians, remember, this is 0.925. And if you remember, 1 radian is about 60 degrees. So if I look at this, it seems like it's reasonable. It's an acute angle. So this is 0.925, and this is 0.925. So if I want to find that CBD, oh, sorry, no, ADB, so I can get ADB is going to be pi minus 0.925, which using my calculator, I go second pi minus that answer I just got, and that will mean the angle is 2.216. So round that off correctly, I get 2.2 radians. Okay, in case I need that, I'm going to put it into B. So now I have these first two done. I need to show that CBD is 1.29 radians. Well, I have myself a triangle here. And so in this triangle, I know that they have to add up to 180 degrees, which is pi. So if I want to find, so part 2 says CBD will be pi minus 0.925 minus 0.925. From here will give me this angle here. And so if I go pi minus alpha A, because I put it in A, minus it again, I don't think A was what I thought it was. Let me try that again. So if I go pi minus this value, and I'm going to minus it again, I end up with what I need to get, 1.29. Okay, so now I know this is 1.29. Hence, find the area of the shaded region. Well, I have to recognize that this whole piece here and here is a sector of the circle, because it told us earlier on that we had a circle here. So I know the sector And then I want to go along, and then I want to subtract away the triangle's area, and that will leave me with the shaded region. And so, putting that all together, we know the last part, we're going to go the area of the sector minus the area of the triangle. So the area of the sector is half r squared theta. Area of the triangle is half AB sine C. I know my r is 6, and my angle is 1.29 squared, and I get 1.29 is theta, minus half, well, this is the included angle is 1.29, it's going to be, so 6 times 6 sine of the 1.29, and if we do this all together, go to my calculator, 0.5 times 36 times the 1.2, let's go back and use the actual value. Delete that part. And in this case, I think I could have used 1.29 because they gave it to me as the value, but I'm going to use the exact value. I'm going to go minus 0.5 times 36 again, times the sine of that angle. Put it all together, and I get the shaded area is 5.94. And that is the shaded region up in here.